In this step of the tutorial, we'll be looking at the results from the simulation. To open up the results window, bring your cursor over to the outline window, and under Results, press Graphics and Animations. This will bring up the Graphics and Animations window. First, we're going to want to look at the entire geometry for our results by mirroring the geometry across the axis. In order to view both sides of the geometry, click Views. We need to mirror the geometry across the axis. So click on the axis, and then click Apply. And then press Close. Next, we're going to want to look at the velocity vectors. Under Graphics Animations, under Graphics, press Vectors, and then press Setup. This will open up the Vectors window. We want to look at velocity vectors. Vectors of velocity, which is what we want. We're going to color the velocity vectors by Mach number. So color by velocity and Mach number. Then press Display. This will display the Mach number velocity vectors in the graphics window. The velocity vectors start subsonic, accelerate to sonic, and are exiting the nozzle at a sonic speed, at about Mach 3. After you've viewed the velocity vectors, you may close the vectors window. Next, we'll be looking at contours of pressure. In the Graphics and Animations window, under Graphics, click Contours and then Setup. This will bring up the Contours window. It is defaulted to pressure and static pressure, which is what we want to look at. Before we click Display, under Options, click Filled. This will just fill in the space between the contours. And also change the number of levels to 40. Then press Display. And that'll display the pressure contours of static pressure. Next, let's take a look at total pressure. To change the contours from static pressure to total pressure, click the drop-down menu next to static pressure and click total pressure, and then press Display. As you can see, most of the nozzle is constant pressure with a little bit of air at the outlet of the nozzle. Next, we'll be looking at the Mach number contours. So come back to the Contours window and change contours of from pressure to velocity and velocity magnitude to Mach number. And then press Display. And this will plot the contours of Mach number in the nozzle. After you've plotted the contours of Mach number, you may close the Contours window. Next, we're going to do a plot of the pressure along the axis and along the nozzle wall. Under Results, click Plots. This will bring up the Plots window. We're going to be doing an XY plot, so click that, and then click Setup. We're going to be plotting static pressure first. The y-axis function is just that, the y-axis of our plot, and we will be indeed plotting static pressure. The surfaces determine which surfaces we will be plotting the static pressure across. So as I mentioned, we're going to be doing the axis, so click Axis, and also the nozzle wall. Also click Nozzle Wall, and then click Plot. This will plot the static pressure along the axis and the nozzle wall. Currently, it's plotting this as points. We want to plot the function of static pressure as a line. So in order to do that, come back to the XY plot window and click Curves. The curve number corresponds to which curve we're talking about. Curve 0 is the axis, and it's being plotted as white points. So we want to get rid of the white points. So under Symbol, choose nothing. And we want a line, so under line style, under pattern, choose the line. And then click apply. We need to change the curve number, and this is the red points that are showing up on our curve, and repeat the same. And click apply. Click plot again, and now our points are lines. Next, we're going to create an XY plot of the Mach number. So under y-axis function, change it to velocity, and change velocity magnitude to Mach number, and press plot. Something else we're going to do here is we're going to include the 1D data for Mach number along the axis. In order to do that, we need to load a file into the file data. So click Load File, browse to the file you should have downloaded earlier, select it, and press Plot. As you can see, it plotted the green points, which is the 1D data, on the plot with our simulation results. In the next step of the tutorial, we'll be looking at verification and validation for the simulation.